And we have liftoff off of Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square. A near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, People freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, hey, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. The red parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022. It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red, the sun is too bright, the wind is all wrong, it's hard to breathe, and there's no water in the ocean. Well, panic not, it's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us: sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild. Layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, the formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For waves to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around, and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists have been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale Crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero Crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels. But future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero Crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, the discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero Crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used 2 special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero Crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero Crater has changed a lot over time. Long ago, this area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life. NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the Red Planet back in its old times. There's this story about an ancient mega-flood that might have happened there. So yes, the Red Planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this mega-flood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that? We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grain than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, We don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now, this theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the fourth planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity, nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays, they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide. At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass.
New research suggests that Mars might have all the necessary conditions for the appearance of life. Does it mean aliens could be already waiting for us on the red planet? Let's figure it out. On Mars, there are just the right conditions for photosynthesis beneath dusty ice layers in its mid-latitudes. And photosynthesis, the process used by plants, algae, and cyanobacteria to turn light into chemical energy, requires water and sunlight. On Mars, a thick layer of ice might filter out harmful solar radiation while letting enough light through to enable photosynthesis, creating what researchers call radiative habitable zones. This doesn't mean that, at the moment, life exists or has ever existed on Mars. At the same time, the findings give scientists clues about where to search for potential signs of life. Both Earth and Mars lie within the Sun's habitable zone, where temperatures can support liquid water. But while our planet's surface is covered with huge oceans, Mars appears dry and desolate. Yet evidence from NASA missions like Curiosity and Perseverance suggests it wasn't always this way. Ancient lakebeds and river channels show that water flowed on Mars billions of years ago. Today, Water exists on Mars primarily as ice, often in surprising locations. Scientists believe Mars lost its liquid water when its magnetic field faded, which led to its atmosphere getting stripped away by solar winds. With little atmosphere left to trap heat, water vapor escaped into space, leaving the surface cold and dry. Without an ozone layer, Mars also faces intense ultraviolet radiation, which destroys the complex molecules essential for life. Mars gets about 30% more harmful UV radiation than Earth. But dusty ice layers could shield potential habitats from this radiation while still letting in enough sunlight for photosynthesis. Using computer simulations, researchers found that dust within Martian ice could cause it to melt from below, forming thin layers of liquid water. These pockets could be shielded from evaporation by the overlying ice, creating the two essential ingredients for photosynthesis: water and sunlight. Past studies also suggest that even small amounts of dust, less than 1%, in dense Martian snow, can enable melting in mid-latitudes. Observations of exposed dusty ice near Martian gullies also support the idea that these conditions could form shallow liquid water layers under the surface. At the same time, the amount of dust in the ice plays a critical role. Ice with too much dust blocks sunlight, while ice with just the right amount, from 0.01 to 0.1%, can create habitable zones at depths of 2 to 15 inches. Cleaner ice could allow these zones to form deeper, between 7 and 10 feet. As for Mars's polar regions, even though they're rich in ice, they are likely too cold for this melting to occur, making mid-latitudes a more promising target. Interestingly, similar habitats exist on Earth, providing an analog for what might happen on Mars. On Earth, cryoconite holes form when dust and sediment heat ice surfaces, melting them enough to create pockets of liquid water beneath. These translucent ice layers allow sunlight to go through, and researchers have discovered microorganisms living in these shallow subsurface environments. While they go dormant in winter, when sunlight returns in the summer, it reactivates these tiny ecosystems. While this research doesn't confirm the existence of life on Mars per se, it does open up new avenues for exploration. Understanding how dusty ice interacts with sunlight and melts could help identify potential habitable zones on the red planet. The research team is planning to refine their simulations to better pinpoint where and when melting might occur on Mars. They're also recreating these conditions in the lab to study them in greater detail. This work could provide important insights for future missions looking for signs of life on Mars.
You must have heard that humans were supposed to fly to Mars within the next 10 to 20 years, but now the mission seems to be at risk. A new study has revealed the dramatic effects that such a journey can have on the human body, and because of that, the entire plan is now at risk. Samples from over 40 missions, which involve both mice and humans, have shown that the conditions in space are likely to have an even more negative influence on our bodies than we thought. Both NASA and SpaceX are planning to send crewed missions to Mars in the coming decades, but new findings might put an end to these projects. Researchers at University College London have discovered that microgravity and galactic radiation in space cause serious health risks, and they become more and more pressing the longer someone is exposed to these conditions. Surprisingly, the body part at the highest risk is the kidneys. The research has shown that after less than a month in space, some parts of the kidneys show visible signs of shrinking. So before we go all the way to Mars, we'll need to develop measures to protect the kidneys and other parts of the body. This will allow astronauts who will take part of this mission to avoid irreversible damage to their health, which in turn means that future missions to Mars haven't been completely ruled out yet. The author of the study, Dr. Keith Sue, mentioned that they already knew about the issues that astronauts had after short space missions, like kidney stones for example, but they still don't know why such problems occur or what is going to happen to astronauts on much longer space flights, such as the planned mission to Mars. If they don't manage to develop new methods to protect the kidneys, astronauts who will eventually reach the red planet might need serious kidney treatment already on their way back. Unfortunately, the effects of radiation damage on kidneys appear pretty late. By the time they become apparent, it might be too late to prevent a kidney failure. This can be catastrophic, not only for the astronauts, but also for the entire mission's chances of success. Meanwhile, an astronaut on Mars is likely to receive up to 700 more daily radiation doses than those we get on our home planet. The Earth's magnetic field and atmosphere protect people from the non-stop bombardment of cosmic rays. These energetic particles travel close to the speed of light and can easily penetrate the human body. In space, astronauts aren't protected against this radiation as effectively as on Earth. which can increase the risk of many serious health issues during long missions. Damage to the human body can extend to the brain, heart, eyes, and central nervous system. Physicists studying cosmic radiation explain that one day in space is equivalent to the amount of radiation one receives on Earth for a whole year. Moreover, most of the changes in the genes of the astronauts are likely to be the result of radiation exposure. That's what a recent NASA's twin study claims. It has shown DNA damage in astronaut Scott Kelly compared to his identical twin and fellow astronaut Mark Kelly, who remained on our planet. Another source of space radiation are the unpredictable solar particle events. They deliver high doses of radiation in short periods of time, which can lead to radiation sickness if astronauts don't take special protective measures. Even space flights orbiting close to the Earth, including the International Space Station, have highly adverse health effects. These days, research communities are focused on musculoskeletal, neurological, ocular, and cardiovascular degeneration, and these issues can appear as soon as a few weeks into a mission. At the same time, the effects of low Earth orbit flights are less clear when we talk about other organs. More research is definitely needed.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaetons was a good story, it's not popular anymore.
Mars has long been a source of mystery and fascination, with numerous anomalies discovered on its surface that challenge conventional explanations. Among the most intriguing is a square-shaped formation captured by the Mars Global Surveyor's orbiter camera. This unusual structure, visible in an image available through Arizona State University's Mars Image Explorer, has sparked intense debate among researchers and enthusiasts alike. Many believe that this geometric formation, along with other peculiar structures on Mars, warrants further investigation as it could potentially reveal artificial or unknown processes shaping the Martian landscape. The discovery of this square-shaped formation has raised profound questions about its origin. Unlike the chaotic natural formations typically seen on Mars, this structure exhibits a level of symmetry and geometric precision rarely found in nature. Most natural geological processes, such as erosion and volcanic activity, tend to create irregular, unpredictable formations. However, the almost perfect angles and well-defined edges of this Martian square suggest that it may not be the product of ordinary geological forces. Some skeptics argue that its unique shape indicates an artificial or intelligently designed origin, pointing to the possibility that Mars may have once harbored an advanced civilization or been visited by extraterrestrial beings in the distant past. If this theory holds, the square formation could represent the remnants of an ancient structure, now partially buried under Martian dust and sediment. One of the most compelling aspects of this formation is its location and scale. The image from the Mars Global Surveyor provides detailed measurements suggesting that the square formation is significantly large, far beyond the scale of ordinary rock formations. Its distinct shape compared to the surrounding terrain makes it stand out as an anomaly, further adding to the mystery of its existence. If it were merely the result of natural geological processes, one would expect to see other similarly shaped formations nearby. Yet this is not the case. This discrepancy raises questions about whether Mars has undergone processes unknown to mainstream science, or if intelligent intervention played a role in shaping its surface. Supporters of the artificial structure hypothesis argue that the square formation could be a remnant of an ancient Martian civilization, similar to the ruins of ancient cities found on Earth. They suggest that if Mars once had conditions capable of supporting life, it is entirely plausible that an advanced society could have flourished there before some catastrophic event led to its demise. Given the evidence of past water activity and the possibility of an ancient atmosphere, this theory is not as far-fetched as it might seem. If Mars did indeed host intelligent life in the distant past, structures like the square formation could be key to understanding the history of the planet and the fate of its inhabitants. Another possibility is that the square formation may be linked to extraterrestrial visitors. Some researchers speculate that Mars may have been used as a base or an outpost by non-human intelligences at some point in history. The precision of the square shape and its distinct edges lend credibility to the idea that it may have been deliberately constructed rather than formed through random geological processes. If true, this would suggest that Mars has played a far more significant role in interstellar history than previously thought. NASA and other space agencies have largely remained silent on the implications of these formations, often dismissing them as natural rock formations or imaging artifacts. However, this stance has not deterred independent researchers and analysts from continuing to investigate. With the increasing availability of high-resolution images from Mars rovers and orbiters, more anomalies are being identified, adding to the growing body of evidence suggesting Mars may not be the barren, lifeless world it is often portrayed to be. The presence of geometric formations on Mars raises profound questions about our understanding of planetary science and history. If the square formation is indeed artificial, it could revolutionize our understanding of Mars and the possibility of extraterrestrial intelligence. Despite skepticism from mainstream scientific circles, the demand for further study of these formations continues to grow. Many argue that future missions to Mars should prioritize the exploration of these anomalies using advanced technology to determine whether they are truly artificial in nature. With human missions to Mars on the horizon, the opportunity to investigate these structures up close may soon become a reality. If we are to uncover the true nature of Mars, we must be open to the possibility that what we find there could change everything we thought we knew about the universe. The square-shaped formation on Mars remains one of the most intriguing and unexplained discoveries in planetary exploration. Its geometric precision and distinct appearance challenge traditional explanations and fuel speculation about its possible artificial origins. Whether it is evidence of an ancient civilization, a remnant of extraterrestrial visitors, or a geological anomaly unlike any seen before, this formation demands further study. As humanity continues to explore the cosmos, we may one day uncover the truth about Mars and the mysterious structures that lie on its surface, revealing secrets that have been hidden for millennia.